All right, we're going to be working with powers and exponents today. So let's look at a couple of examples. Let's say you had a problem that looks something like this. Let me get my pen here. All right, here we go. If a problem just says something like 2 to the third power, we already know that that means 2 times 2 times 2. All right, 3 of those 2's. That exponent tells you how many times the 2 will be used as a factor. When that's a 3, you can count 1, 2, 3 of those. If that was a 4, you count 1, 2, 3, 4 of those. All right. We know that these 2 right here means 4. 2 times 2 is 4. And when you bring that other 2 down, that now this here means 8. 4 times 2 is 8. All right. Now we're pretty much aware of that. But this is what I want to get to. Suppose you have a question that looks like this. And it says 2/3 raised to the third power. Okay, I want you to look at this 2 ways. The first way I want you to look at it is you're going to take the 2/3 and you're going to write that 3 times. Because the exponent is a 3, that means it's going to be raised to the third power. So you will see the 2/3 used as a factor 3 times. Now you can simply multiply straight across. 2 times 2 times 2 is 8, and 3 times 3 times 3. Keep this in mind. 3 times 3 is 9. 9 times 3 is 27. All right. Now, that's the answer. But I also want you to look at it like this. For some of you, this may be easier to look at it like this, and others will prefer the method I just did. All right, if this is raised to the third power, I want you to understand that that 2 is raised to that third power. So there's an exponent right there. So it will look like this, 2 to the third power. Over that 3 right there is also raised to that 3 right there. So this is 3 to the third power. So whenever you have a number inside the parentheses, that 3 on the outside will be distributed to the numerator and the denominator. So you can simply look at 2 to the third power is 8, and 3 to the third power is 27. It's a little bit quicker to look at it like that. But this one here expands it all and shows more work. So let me do one more example so you can get the idea of that. If I have, let's say, 1/4, and you raise all of this to the second power, that would mean, if we use that other method, that would mean that 1 would be raised to the second power, 1 would be raised to the second power, and also that 4 would be raised to the second power, 4 will be raised to the second power. Okay? And that would mean 1 over 16. Because 1 squared is 1, 4 squared is 4 times 4, which is 16. Now, look at this. Suppose I take that same 1/4 and I do this. 1 over 4, and I put a little 2 out here like that, and I don't use any parentheses. What would happen now? Without the parentheses, that exponent only applies to the numerator. So in essence, that would be 1 to the second power right here over 4, not 4 to the second. So this would just be 1 over 4. Okay, let me do that again. Suppose I have, again, a number like 2/3, and I have a raised to the third power right here. Well, that third power only applies to the 2, not to the denominator. I would have to have parentheses around the whole thing to apply the 3 to the numerator and denominator. So the way it's written right now, this would be, if I expanded it, 2 times 2 times 2 all over 3. Okay? So that would be 8 over 3. Okay? But if I took that same 2/3 and I put it inside parentheses and I raise it to the third power, everything inside the parentheses is being raised to the third power. You got to understand the difference there, okay? So that again would be 2 to the third power over 3 to the third power, which is 8 over 27, as we said before. All right, very good.